Okay, thanks everybody for your patience. I'm now driving Office 365 off a Lumia 920 on wireless connection, so we'll see how we go with the demo. Thanks for coming. The session I'm going to talk about is, it's very, very IT pro. If you're a dev, any devs in the room? Any hardcore devs that hate IT pro? If you are, it's time to leave. This is going to talk about search components, search capabilities, so a little bit, and mainly about the architecture and components within the platform. I'm Neil Hodgkinson. I'm a Microsoft employee working for the, well, technically the SharePoint product group, as it used to be called, Microsoft Office Division 365 Operations. So any of you out there that have got 365 tenants, if they start falling apart, I'm usually the guy that gets the call when everything really breaks. So no difficult questions at the end. I've been fortunate enough to go through the Microsoft Certified Master Program 3 times for the 2007, 2010, and 2013 program. And I'm an instructor on the 2010, or was on the 2010, now the 2013 platform for enterprise search, SQL Server technologies, and business continuity management. And I used to be a chemist, working in drugs, explosives, and poisons. So don't upset me. So what we're going to do, we're going to do a bit of a history lesson. Steve talked about this conference being very much an evolution of the product. So we're going to look at evolution of search, only from the kind of last couple of versions. Nothing, not going to go back to index server or anything like that. We're going to look at architecture and scale considerations. I do have another session on Wednesday where we will actually do live scale out of search. We'll build search components and we'll scale out the platform in a real demo. In this session, we're just going to talk about some of the considerations you need to think about, scalability touch points, like, if I've got X number of items or I want so much requests per second, what do I need to think about building? And then we'll look at admin features and capabilities. Really the second part of the whole session is really around admin features. And for that point, the reason I needed to get the demo working is because about the last half an hour, maybe in the last 20 minutes of the session, is entirely demo driven. So if we lose that, you're on an early lunch, so you won't be able to get the queue early. We'll see how it goes. Takeaways, really to appreciate decision points. Why did Microsoft make the fundamental decision to scrap several of their search products and really consolidate the platform into one? Understand the building blocks. So we're going to talk about all the different touch points, all the different components that you need to make your search platform work. Realize scale considerations. So here, as I said already, we're really going to look at, what do I need to deploy to make it better? Not going to go into depth about how many CPU cores you need, how much specific amount of memory you need. That's a session for Wednesday. We'll go a bit deeper on Wednesday. And then understanding improvements to site, farm, sub-site selections, and farm administration from a SharePoint search perspective. I would encourage you, if you want to see how these components are actually used in real world, in real scenarios, in business cases, there's 3 other sessions this week. Agnes Molnar, Matt McDermott, and John Holliday are doing some really good how to implement and use search, whereas we're going to talk about what the building blocks are. So those are the sessions you need to go and see if you want to see really funky front-end stuff, see some customization of result types and result sources and those kind of things. So the first thing we're going to do is look at search evolution. So where does a product go? Where does it come from? As you know, there's hundreds of search products out there in all kinds of different flavors. Obviously, in SharePoint world, we're primarily concerned with SharePoint itself, with our competition, which does include Google when we think about Google appliances and other platforms, autonomy, those kind of things. There's lots of other platforms out there. And obviously Fast. So Fast formerly being a competitor of Microsoft, now actually part of the platform. By the way, does anyone know how long ago it is since we bought Fast? 5 years? Yeah. So it's took a long time to get where we are today in terms of the product's evolution. So think about what we are. We've re-architected the platform completely. It isn't a case of levering Fast into SharePoint. It isn't a case of pick up some Fast ESP bits or Fast Search for SharePoint bits and just plug them into SharePoint. It wasn't that simple. The way the product was re-architected, back in 2008 when Microsoft purchased Fast, we were looking at, or Fast were doing a lot of research and development on a new core for the Fast engine. And that core today is what's now inside SharePoint. So it's come forward all the way through the Fast pipeline, been developed, and it's now a completely new engine. Lots of the same technology, lots of the same capabilities, but a very different development platform. And then really, from a SharePoint perspective, in terms of how we kind of merge the two together. The easiest way to think about it, there's a friend of mine, Mitch Prince, who talks about this kind of paradigm for SharePoint. Think about SharePoint and Fast as being the mummy and daddy of a relationship, mother and father. And then they got together, they got married, and they had a little baby. And that baby was SharePoint 2013. So it has a lot of the genetics of both products. There's pieces of SharePoint 2010 in there. There's pieces of, in fact, there's pieces of Index Server too in this platform. There's also a whole lot of stuff from Fast. So we're going to see the bits and pieces which has come from where now as we go through this session. So SharePoint Search was derived from Index Server. It's been a platform that's been around for a long time. There was obviously a lot of scalability issues as we went through time, through 2003 and 2007. With 2007, everybody complained about the single indexer and the fact we 2010 we brought in high availability. So that was kind of the big win in SharePoint 2010. For Fast, different engine entirely, totally different concepts. Any Fast consultants or Fast? Anyone got Fast running in their infrastructure? A few of you, okay. So a lot of the terminology will make this make sense to you folks. Hopefully it'll make sense to everyone else when we get to the end. So Fast is a very different platform, very separate, very distinct in terms of components. A different component for every single aspect, if you like, of the index. And with SharePoint, we had to think about how we're going to re-architect this platform. How are we going to make SharePoint 2013 to be the best of both worlds? You know, take the good bits of SharePoint, the good bits of Fast, merge them together, generate this platform that's both scalable, performant, and easy to administer. You know, one of the difficult things about Fast sometimes, especially if you work with the ESP platform, administration was a little bit difficult. SharePoint was much easier, but it was a less complex, less powerful product. The idea here is to get both together. So from a re-architecture perspective, there was two main drivers, complexity and confusion. From a complexity perspective, imagine being, there's some of you developers in the room, imagine being the development team who have to manage and control all of the patching, all of the upgrading, all of the process improvements and the fixes from multiple search platforms. So you're having to look after the desktop search experience, the SharePoint search experience, the Exchange search experience, and now bring in Fast, another platform. All these dev streams and cycles, incredibly complex. You know, sometimes 3-4 times the maintenance cost of a single product. And then confusion. Which search product actually gets me what I need? Which search product do I want? Do I need Fast? Do I need all the cool, funky stuff that Fast does? Or is SharePoint enough? Is Foundation Search enough? Is Search Server enough? So the idea here is to bring it all into one place. And in one respect, take the choice away from people, but also give them the flexibility in the product such that they get all of those choices they would have had to make inside one product. And they can choose which pieces they want to use. So, how to do it? Main thing was common architecture. So I mentioned already about levering this version of SharePoint or version of Fast into the SharePoint platform. So we needed to hit all these targets. It needed to be performant, it needed to meet all the business scenarios we needed, the internet, the enterprise, and the anonymous searching capabilities. Easy to install and use. If any of you installed Fast Search for SharePoint 2010, especially at scale, it's a right pain. Okay, you know, sort of swearing, I'll leave it at that, but it's not the easiest thing in the world to install. We had to get rid of open source. So the Fast platform was full of open source components. It was full of things like Python libraries and all kinds of things like that we really didn't need and didn't want in a product that Microsoft was going to sell. It had to be cloud friendly. So more importantly, for the 365 perspective and other hosters that want to host SharePoint, it needed to be easy to use. It needed to support the concept of tenancy and data separation. We needed to support all of those tenants in terms of the platform architecture for supporting cloud. And then finally, Exchange friendly. So that you may or may not know, but in Exchange 2013, Microsoft decided to abandon the entire Exchange search index platform that they had inside that product. And Exchange also has a version of SharePoint Search inside the Exchange engine now. So it's basically another way of reducing the impact and another way of reducing the complexity of the product stack. And we ended up with SharePoint Search. So this is kind of a halfway house, if you like, or a merging of the two versions. And what we're going to look at today, over the next kind of 20 minutes or so, is all of these different components to a certain level of depth. If you want to know more information, we can talk about after the session. But we're going to talk about the crawl engine, the processors, the indexer, and some of the aspects of what they do and why they do it. The other thing to think about is we're also going to talk about which bits come from Fast and which bits come from SharePoint, because some of it's the same. From an infrastructure perspective, we also need to consider things like the services, the components, and the databases. So SharePoint has a footprint. It has a requirements in terms of product deployment. So first thing you'll note when you deploy SharePoint to 2013, I guess you've all deployed SharePoint 2013 and used search. Yeah, I'm assuming no hands up means everyone's hands up, yeah, hopefully. So you'll see that with SharePoint search now you get these two services. There's a SharePoint host controller. Those of you that are familiar with FAST will be familiar with node runner processes, and this is the guy that controls those processes. And then there's the SharePoint Search Server 15, and that primarily is responsible for crawling content and nothing else. That's all it does. So the host controller spins up all of these. Do I have a pointer? I do have a pointer. You can't see anyway. Okay. The host controller spins up all of these node runner services. So within that previous diagram, we saw the analytics engine, the content processor, the index, query processing, and search admin. These are the things we're going to talk about as we go on. It's the host controller service that does that. So if you're just familiar with SharePoint search, this is the very new stuff. This is the stuff you won't have seen before. All of these different aspects, apart from the analytics, which is very new in SharePoint 2013, of course, all of the other things like query processing, on-disk index, the actual index pipeline was previously in SharePoint world all hosted inside MS Search Exe. So now we've taken that away, and that's where the fast engine comes in. SharePoint itself, or the SharePoint piece itself, is really just the MS Search Exe process, which is only responsible for crawl. So all that process does is go out and collect content and feed it into the FAST, or the formerly known as FAST content processing engine. So it's quite a lightweight service now. You shouldn't get kind of problems that we'd seen previously with MS Search Exe, like excessive CPU usage. Unless you really try and tweak and tune that process up, you won't see so much of that these days. There is still a memory leak in the platform, though. We haven't got rid of that yet. So you will see excessive memory use on MS Search. So I want to give you a quick look at the search service application. I'm assuming most of you've seen Central Admin, so I just want to give you a very quick overview of what the search service application looks like. And primarily, the reason for this is to show you why it's not much different in terms of what it looks like, for those of you that may not have seen it. So hopefully this will come up. My session won't time. No, there we go. Okay, so those of you that are familiar with SharePoint, hopefully all of you, will be familiar with the usual way we get into search service administration through managed service applications. We find our search service application down here, select it, manage, and apologies for the resolution. I don't want to drop this session because the network's playing up. If I'd lose it, we'll lose all the demo. So fundamentally, oh, where'd I go? Fundamentally, it looks much the same in terms of what you see. Apologies for this, it's going to be a bit mad. I'll try and fix this for the next demo, but the network, I don't want to drop the connection. Fundamentally, very similar to SharePoint 2010 Search Service Administration interface. We have our usual set of highlights at the top showing where our search administration service is running, how many items we've got in the index, what's our average crawl rate. Looks pretty similar. So here we're looking at a server that has 3.3 million items in the index. It's a tiny one, really. 0.8 queries per minute, low number of queries per minute. This is live data, by the way. This is a real platform. And then we can see the other aspects in terms of the search application topology. And here's where things start to look different. So the application topology, we see different roles, admin, crawler. I'll slide that across a bit. And the key thing that's missing from this interface, which we will talk about quite a lot on Wednesday, is there's no modify topology button. So there's now no way in the search interface to modify the search topology without using PowerShell. You have to do everything through PowerShell, and we're going to do that on Wednesday as a demo. Apart from that, these things change a bit down the side, and we're going to demo. I'm going to go into each of these in turn in part of the later demo to show you some real diagnostic data and what a real search platform looks like in the next demo. But fundamentally, it should be familiar to all of you from a search service administration aspect. There shouldn't be anything new or different in there. Okay. So that was the easy demo. Hopefully my phone will keep working. In terms of the components themselves then, I want to walk through each of the individual components and just call out some aspects and some properties of those components that are important for when you as the search admin or you as the owner of the SharePoint platform need to think about when you're deploying search and when you're potentially scaling out search. So the first thing that comes to mind is the search admin component, basically the heart and soul of the system. Think of the admin component and its database as being like your SharePoint, your SP admin service and your configuration database for the SharePoint file. This is as important that the search admin DB is as important to search as the config DB is to the SharePoint file in its own right. It's responsible for provisioning. You're talking to this service every time you make a topology change. Every time you go and kick off a crawl, it's this service that you're interacting with. It's this service that's doing all of the hard work behind the scenes. One of the changes in 2013 that we didn't have in 2010, you can deploy multiple admin components. And it's recommended that you always deploy multiple admin components for high availability. Reason being, if you lose your admin component, while you can still continue to search, you will no longer be able to index. So your ability to crawl content will fail. Your ability to make changes to the system will fail. So the admin services, while not as critical to the end user experience, as an administrator, it's very critical to your experience because you can't do anything without that guy running. So you have two, and they basically take turns owning the DB. So you're always talking to one of them, and they go through a kind of a polling process, a voting process, if you like, to decide which admin component is going to be responsible for the database and which one is going to be making the changes. But have two, always have two. And the search admin DB, the majority of it remains the same. So it contains information about the topology. So all the changes you make when you're talking to the admin service are propagated into that database. So you make changes to the topology, any crawl rules or query rules you make, any changes to the search schema by modifying managed properties, for example, they're all stored inside this database. One thing that it doesn't store anymore is ACLs. So we no longer store the security descriptors of our content in this database. So that means that we've got less reliance on it. So when you're doing a query, for example, if you haven't tuned your security cache on the search engine to store many more items than it does by default, in 2010, you would be constantly potentially polling this database. Every time you do a query, the default cache size on the search admin service was 1,000 items, 10,000 items post SP1. 10,000 items post, I think it was the October CU last year or something for 2010. In 2013, we don't have that reliance anymore because we don't store these ACLs in there. The ACLs are stored in the on-disk index alongside all the content. The performance of the search from a security trimming perspective is much more performant. So it's just a key change, makes a big difference in terms of the performance of your database engine. Then we come to look at the crawl component. So this is the guy that's hosted by MS Search Exe. This is not a node runner process, it's not a fast process. We still use the same MS Search Exe process that we had in 2010, with a few changes. But primarily it's responsible for reaching out to your content sources, whether they're SharePoint sites, file shares, websites, Exchange, whatever it might be, and it just collects content. It loads a protocol handler, it reads the content, brings the content back to its on-disk cache, and that's it. It does nothing else. In 2010, it used to do all the document parsing. It used to load iFilters. It used to crack the content, do the word breaking, do all of that really heavy lifting hard work. In 2013, that's not the case. The search process or the crawl component does exactly what it says. It's a crawl component and nothing else. We hand all of the hard work off to the content processor. So you don't need to be too concerned with that. It does a few bits and pieces like gather some metadata, but primarily it's only concerned with capturing data. The crawl database, different to 2010 from a pure SharePoint perspective, but very much the same from 2010 if you were using fast search for 2010, in that it contains all of the information about the crawls that were done, all the crawl URL information. So while we don't encourage people to look at the SharePoint databases at all, and certainly not change them obviously, it is a very, very useful source of information for doing things like, well, if I crawl this item and it's generating errors for me, how do I know how many errors it's time? How many times have I tried to crawl that item? The only way you can surface that information is from within this database, and it is in there. So take a copy offline and read that information over there. There's a lot of very useful information in that database. One of the things that isn't in there is anchor crawl content. So the anchor crawl, for those of you who don't know, is the process that takes place at the end of a traditional crawl where the search engine has to look at all of the hyperlinks between objects, all of the connections between objects inside the search index, and modify the ranking algorithm to say, okay, this item is connected to 10 others, therefore it must be more important than this other item that's only connected to 4, for example. The anchor processing engine inside SharePoint 2010 was horrible because it was a synchronous process that occurred at the end of the crawl. There was no way of knowing how long it was going to be and how long it was going to take. So what happened was when you were running a crawl, at the end of the crawl, you ended up with this little box in your status, or this little status mark saying computing ranking, and that's the only information you had that you were in anchor crawl phase. In 2013, we don't do anchor crawl through the same database. Anchor crawl is done by the analytics engine, still part of the search engine, but asynchronously. So we can complete a crawl and start another crawl immediately without having to go through all this anchor processing content. And anchor processing is terrible. It's a really resource hog on the system. In terms of the crawler and how it works, we've modified the crawler architecture as well. So did anyone run into the problem with having, okay, anyone got more than 25 million items in a search index? I know that's a bit of a, yeah, one over there. Okay. With 2010 or with fast? Okay, so it's a different scenario, it's a different story with fast. But in 2010, the supported limit for a crawl DB was 25 million items. And when you were crawling, you could only crawl one web application, or should I say one web application could only be managed from a crawl perspective by one crawl DB. So the start address, the intranet.contoso.com, was added to what we call the crawl queue in the crawl database, and then it was crawled up line by line, effectively, all of the items in that index. You couldn't spread it across multiple databases. And we had a 25 million limit on the crawl DB. So by inference, if you were using search on a SharePoint platform, you were instantly limited to 25 million items on a web application because we couldn't crawl it otherwise. Technically we could, it didn't break, but you were going outside the supported boundaries. So there was a potential risk of performance issues, potential risk of support issues if you ran into any scenarios where you needed support for that system. Now, I've successfully ran a crawl DB on 2010 with 115 million items in it, so it's not a big problem, but it's not a great story. It doesn't make sense. In 2013, we changed that all up. So in 2013, in 2010, we had this thing called host distribution rules that would let you target particular web applications to particular databases. In 2013, the host distribution rules are deprecated. We don't need them anymore. In fact, they're not deprecated, they're gone, totally gone. You can't use them even if you wanted to. Instead, we've modified the crawl engine such that any single crawl component can now talk to all of the crawl databases, and all of the crawl databases can crawl or can crawl the URLs, or can have a crawl queue containing the URLs for all of the web applications. The difference being we split down what we call content DB affinity. So whereas in previous versions we had a URL or a single host name or start address contained inside one database, now we can take all of the content databases within that web application and they get spread across multiple crawl databases. So it's a different level. It's like a step lower in the architecture, step lower in the logical architecture of the platform. It means we can spread more information across more crawl DBs. It leads to faster crawls, and it also allows us to support this new thing called the continual crawl process. We couldn't do that previously without the architectural changes. And this 25 million item goes away. So we still have a 20 million item limit per crawl DB, but all we have to do now is just store more and more crawl DBs. We can have more crawl DBs. And our limit now has gone from, instead of being 25 million per web application, it's now 20 million per content DB from a crawl perspective. So it's a much more performant, much more scalable architecture. In terms of the process changes then with crawl, so the key one I mentioned already was continuous crawl. There's no notable changes in full and incremental, so you'll be familiar with those processes. Full crawl crawls everything, incremental picks up changes. There's a few slight changes in error handling and things, but fundamentally there's no real changes in how those actually work. However, we have this new type called the continuous crawl, which is a bit of a misnomer because it isn't really a continuous crawl. It's kind of a very fast, frequent, slight, almost an incremental. But the way it works, so the limitations we had with 2010 and the limitations we had with all the previous versions of SharePoint, when you were looking at incremental crawls, the scenario here, if you look, was this was a traditional incremental crawl. The ideal scenario is you do a full crawl at the beginning, and then every crawl after that is an incremental, and it completes within the time window of your incremental schedule. So if you set a schedule like this every 15 minutes, you ideally want every single incremental crawl, so these are our incremental crawls here. Each of those you want to finish in less than 15 minutes, so then you're ready to start the next one. In reality, does it ever happen? No, because someone goes and changes the web application policy and you ripple 100 million security changes down across your entire platform. And you end up with a scenario at the bottom, where in fact what you actually get is longer extensions of the crawl times. So the guy that made a change here actually won't see his item in the index until here. So if you're doing fast, a lot of important document publishing, legal publishing that has to be, it's time sensitive and time critical, this causes problems. Because you can't predict it, it's very difficult. You just start a crawl and you sit and wait and, well, maybe it's going to take so long, we don't know. Without investigating the database, you don't know how long it's going to take. With incremental crawl, we're sort of here with continuous crawl, but that story changes, because now, whereas previously we couldn't run a single crawl in parallel with another crawl on the same content source, that's the important thing, now we can. So we basically have one continuous crawl session. It's not multiple continual crawls, and all of your content sources that you make available to a continuous crawl are crawled by the same crawl sequence. So if you like, you have this continual ring going round of continuous crawl, which is effectively a single MS Search exe process that's just constantly looking for changes. And then you basically say, okay, well, my content source is important. It needs to be in the continual crawl cycle. I'm going to drop it into there, and you tag it as being part of that cycle. And then as that cycle runs, it goes and looks at your content source. So you don't have your own continual crawl for your content source. It's just one, and they all join in together. And the way that works is, when we look at our crawl cycles, we don't care whether we have crawls that overlap, because we start another one anyway. So the basic just picks up. It just keeps running and running and running. And by default, every 15 minutes, we start off and go and look in the content databases and we'll look at the changes that have occurred, and we add those changes to the crawl history, to the crawl URL table, the crawl URL queue, and then we start crawling them. So it's effectively means that you can potentially add an item to the search index, and it should appear very, very quickly, way, way quicker than it ever could with SharePoint 2010. And you can shrink that cycle, that amount as well. 15 minutes is the default. We have a platform in 365 that's running with continual crawl on a 4-minute cycle. And it's pretty good. It depends on your rate of change, and you have to think about the metrics and how often you make changes. But realistically, this thing runs extremely well. So every 4 minutes we have in 365, we have a continual crawl kicking off. And these things just keep going. If one of them might take 6 hours to complete, we don't care. We just add the changes to the next one. It's fine. And that works out the box. So in terms of content processing side of things then, with these continual crawls are running, or your incremental crawls are running, full crawl, whatever it might be, the MS Search exe process responsibility is, as I said already, to gather that information and then drops it down to disk. So on the crawler, there's a temporary file location. And then from that disk location, the data gets pushed to the content processor. And it's the content processor that does all of the hard work. This is the guy that's going to load the iFilter. This is the guy that's going to load these new things we have called format handlers. So those of you familiar with adding PDF, for example, is the classic one. Everybody adds a PDF iFilter to SharePoint 2010, because everybody needs PDF documents usually. In 2013, you don't need to do that anymore. So we provide you with PDF indexing capability through what we call a format handler. The downside is the format handler doesn't really match all of the capabilities that Foxit and Adobe, for example, can give you today. There's some limitations. The second downside is you can't change it. You can't take our format handler out and replace it with Foxit or replace it with Adobe. You're stuck with what we give you. And there's no intention to provide you with that capability either. However, we do intend fixing the problems, so it will hopefully be a better story. But the key thing is, you can't add your own custom format handlers today. There is a longer-term plan that you'll be able to do that. So today, if you want to do custom filtering, you need to go through the old process, the traditional process of using the iFilter route. So you can still use generic iFilter plugins. But like I say already, you can't replace what's in the box already. And fundamentally, this content, all this process is doing, it's grabbing the documents, it's loading the iFilter, it's breaking them apart, it's doing all of the work in terms of transformation, linguistics processing, all the word breaking work, and basically to give or provide a document, if you like, as an easy way to think about what's provided, that is sent to the index component. And it's the index component then where we talk about the writing the component on disk, where we look at actually storing information. Oh, gone out of cycle. The index component is the guy that then stores the information on disk and is responsible for retrieval of that information from disk. Secondly, the new part of the search engine, from a component perspective, is the analytics engine. Now the analytics, I was undecided whether to put the content processor in next or the analytics engine in next. And fundamentally, I went to the analytics engine simply because it's so important. Everything you do inside SharePoint, so we mentioned the anchor crawl previously. This links DB is now the guy that receives those anchor changes. The event store, it picks up tracks information about everything that you do inside SharePoint. Whether you open a document, you visit a site, you search for a document, you click a link. It's all stored either in the links DB or the event store DB, and it's processed. That data is then managed and processed by the analytical engine, which talks to the content processor, which feeds that metric information, which feeds that content into the search index. So it's another route of data into the search index. So when you go out there searching for something, you search for SharePoint in your intranet, this guy knows you've done it. This guy's added your previous search to the search index. It checks what link you followed. Did you go for item 3 on the page? Did you go for item 4 on the page? All that information is added to the search index. So it means that when someone else comes to search for that information, they know about previous things, they know the previous thing you've searched for, it bubbles up the ranking and improves the relevance of the search results. It's all done through the analytics engine, as well as everything else that the analytics engine does, which is all of the usage calculations and all of the usage metrics and reporting. That's all done out of there as well. From a query side, again, this is formally a fast component, if you like, and we now have this concept of what we call the query processor. In reality, it looks more like this, in that we have what you'd be used to seeing search service application proxy. We have a SharePoint service called the Query and Site Settings service, and that's your query processor endpoint. That sits on whichever machine you provision it on, and it talks to the query processing component, which talks to the indexer nodes. Now on Wednesday, we'll talk a bit more about index partitions as well. Primarily, the concept is similar to 2010, although there's a few changes, which again, like I said, we'll talk about more on Wednesday. But the fundamental thing is that the query engine or the query processor is going to get your incoming query. It's going to decide which query rules to invoke. So as I said already, John Holliday, Matt McDermott, Agnes are going to talk about query rules and things. Transform your query into something else, possibly. Submit that query to the query processing engine or to the on-disk index, retrieve the results back, and then feed that information back to you. So it's kind of the man in the middle between you and the search index. And then the index component, which is on disk, is where the index is stored. So we don't have a property database anymore. That's gone. All of the metadata that was previously in the property DB is now stored in the on-disk index. The on-disk index effectively consists of 6 sub-indices, each of which contain different things. There's an index for ACLs, for example, which we've mentioned already. There's an index for metadata. There's an index for people. There's an index for keywords. All those kind of things are stored on disk. And they're stored in a format that gives us, or can give us high availability and can give us extreme throughput and performance. And fundamentally, the key thing that's different from this, from 2010, is that not all replicas are the same. In 2010, when the crawler was doing the indexing, it would send its changes out to every single partition on the search index that needed to receive an update. In 2013, we have this concept of not all replicas are equal. So we only send updates to what we call the primary replica. So in this scenario here of a simple architecture, in partition 2, for example, this replica and this replica, one of them will be classed as the primary, and the others will be, well, you could call them replicas, you call them secondaries, whatever you want to call them. Only one of those replicas receives the updates from the content processor. That replica is then responsible for propagating those changes everywhere else to the other replicas. And that's a key difference in this version of the product. It's fundamentally different. It actually means potentially less load on your network as well. So it's an easier process in that regard. So we're going to talk a little bit about scale out. As I mentioned earlier, I've got a few slides on scale out. More so, we're going to come and talk about when we look at on Wednesday in terms of administration. So from a scale out and optimization perspective, when we look at these individual components, there's 2 real key rules. Split your, or one rule that has two tenants inside it. Split your bulk processing from the query traffic. So this is important. Bulk processing tends to be significantly CPU intensive, whereas query processing is generally lightweight, with the exception of a few odd, strange queries, depending on how you build them. So the key message is, don't try and run, for example, crawl with content processing at the same time. Running that on the same box is just going to lead you to performance issues. and a requirement to scale that box up. Whereas I'm going to show you a matrix in a minute that gives you some kind of rough rules of thumb. And avoid sharing critical resources. So the key thing, as I mentioned already, crawl and content processing, you wouldn't necessarily want them on the same machine because they have similar characteristics. So where you have two processes that are very CPU intensive, separate them out. It's common sense. It's common sense architectural guidelines. Looking at what we can share and what we can't share. So content processing, in theory, you should share with analytics processing. They're different. They have different characteristics. You can have search administration running with crawl. Now, search admin and crawl, that was the same guideline we had in SharePoint 2010. The reason being, when your platform's crawling, it's unlikely you're going to be making changes. In some cases, you can't make changes. So therefore, the administration service is generally dormant at that point. So all the work is being done by the crawl engine. And then the on-disk index with the query processor. And the bottom chart in the bottom left there, I've actually got a bigger version here. This is kind of a rough guideline. If any of you saw the session at SharePoint Conference by Barry Waldbaum, this was kind of at the time, the latest and greatest kind of guidelines in terms of what you can share. So realistically, what we say is, try and keep things that have 3 stars in one column away from things that also have 3 stars in one column. Sharing a 1 and a 2 is okay. In some cases, sharing a 2 and a 3 is okay, but never have 3 and 3 together, because it would just lead to performance issues. So this is kind of a rough rule of thumb. So you wouldn't put content processing with your index, for example. That would just be a bad idea. It's just going to lead to performance issues. From a scaling perspective, and we'll talk more about this on Wednesday, these are just kind of rough guidelines. It gives you a kind of an idea about the different databases, so the 4 that we have: crawl, link, analytics, and administration. And rough guidelines in terms of how big they might get. I don't know how big your search platforms are. When you get to 10 million items, 15 gig of data in a crawl DB is quite small. In 2010, when you had all the anchor processing stuff in there as well, that could be quite a big database. So there's less of a footprint these days. As you get bigger, 100 million items, 110 gig. So they can be big. I mean, as we've said, not many people in here have got that many items in their databases. But this just gives you an idea of how big these databases might get, what kind of things you need to think about in terms of provisioning SQL Server for them from a scalability perspective. And admin DB, generally quite small. It's a bit like the config DB, not an awful lot going on in there. In terms of scaling for size then, this gives us an idea of how big we would make things. And like I say, on Wednesday, part of a demo, we're going to build out the search infrastructure. I'm going to have 4 or 5 search machines, and we're just going to build the thing out and see how we do it. But this just kind of gives you an idea of what you can build. So how many crawlers you might need, for example, for the number of items, the limits on the crawl DB, analytics. So use these mainly as reference. You'll get the slides. They're the limits as we know them today. The search engine is still going through a lot of research. You'll notice any of you got 365 tenants on SP15 will realize that there's a key web part that's missing, the content by search web part, that everybody wants to get back on the system. It's available on-prem. It's available in the product. You just don't get it in 365. The reason being is all this testing is still not complete. We don't know how big a query infrastructure we need to build to support that level. We don't know what people are going to do with it. So until we've gone through a lot more testing, we don't really know. So these numbers, this might be a case of, hey, well, content query processing components, if you've got this many items, you need 2. But if you turn on the content by search web part and you've got 4,000, 5,000 users doing parallel queries, you might need to have 4. That's the information we don't know yet today. And the worst scenario for us would be to turn on the content by search web part and 365 goes offline again. Happens. From a performance perspective, this kind of gives you the idea. So we mentioned the content by search web part is a key one. Availability of query capabilities, time for results to be returned, or query latency. Those kind of things are dependent on the number of components you have in the query layer. And it's key. It's critical. If you don't have enough query components, your latency goes up. Your latency goes up, your users get annoyed, they stop using the system. So it comes down to the business thing, all about adoption and usability. So that was kind of part 1. Brief history of the platform, services, components, databases. There's an awful lot more stuff we could talk about. We could do a single session on one of those components, but for the case of an overview, it gives you a touch and feel of what's actually in there. From a scaling perspective, like I said already, Wednesday session will cover much more about the scalability and the scaling of the platform. In part 2, I want to really look at search administration changes. So we're not doing bad for time. we're really to think about the search service application that I just showed you a minute ago, what's in there, what it can do, look at some of the features, and look at some of the changes at the site collection level and the site level as well. Like I say, the other sessions by the other speakers will cover actually configuration and making use of those things, but I just want to show you where they are. So, search admin. I'm going to try and drive all of this by demo if it works. So, we'll see how it goes. So I do have a bunch of other slides in the deck, which was in case this didn't work. So I'll get through this in about 10 minutes. Well, I'll try and keep it quick, and we can touch on the other slides and if people want to see them. So we're back to our search service application. So let me refresh that. He says. There we go. Okay, so the things I want to show you basically are the items down here. So here's our search topology. Like I said, we're going to look on Wednesday more about the search topology and what's actually going on inside there. There's nothing below here other than saying about the databases. So this is similar to what you see in 2010. If we go forward and look at the items I want to show you, again, apologies for the resolution. Let me see if I can get it a little bit better. No, not really. We're going to kind of look at down these items on the left-hand side. So the first thing we're going to look at, I'm going to do diagnostics last. The first thing we're going to look at is content sources. Now, you've been familiar with adding content sources in SharePoint 2010. If we go and look at some of these in here, we're going to edit this guy. He says. Where's my link gone? Come on. Can't be that bad. Sorry, this is just the network connection's terrible, and I don't want to drop the VM and resize it, because if I do, I might not get it back. Let me hide that. There we go. There we go. Okay. First section of troubleshooting. So we have same as before in SharePoint 2010. We have our name, content source, status, crawl type. Continuous crawl status, you can see this isn't enabled, so it's not turned on this one. It's regular incremental crawls. And if we look down, we see a URL, and the one thing that's different in this one, at the moment this is a regular incremental crawl. So it's running incremental crawls every 4 hours and a full crawl every 9 p.m. every Friday. If I was to do this, and enable continuous crawl, you see we still show this thing, which is weird. You think that'd be grayed out. I can still go and configure that, but it won't do anything. So in the RTM version of the product, that box is now, even though it allows me to make changes, it's actually disabled. So you can't run continual crawls and incremental crawls on the same content source. It's not allowed. You can do fulls though, and the guidance would be that you still do a full. I wouldn't say a frequent schedule, but maybe it depends on what your data is, but every couple of weeks. The key thing being that a continuous crawl has very different replay logic. So if you're crawling content and it starts to error during the continual crawl process, unlike the incremental crawl and the full crawl, the continuous crawl will not go back and retry. So if you fail crawling content, it will not retry till the next cycle in the continuous crawl process. Whereas the incremental crawl and the full crawl will actually retry several times within that same crawl. So we still recommend that even though you're running continuous, you still go back every now and again and do a full to sweep up all the changes. In the background, there's also what we call a cleanup crawl. So when you enable continuous crawl, every 4 hours, there's another crawl that runs behind the scenes that's cleaning up all the errors from the continuous crawl process. So you don't end up with this enormous error log. It cleans all that stuff up. So the full crawl is really used to go back and mop up all of that stuff. So you get back to a full situation where your full crawl has basically refreshed everything in the index. And the key thing when you're running the full crawl is the continual crawls still happen at the same time. So when you start a full crawl, you're not having to wait for that crawl to finish before you start picking up new changes. The continual crawls will still run in parallel. But you can't do incrementals with continuous. Other thing, crawl rules remain the same. No changes there. So I've got a couple of changes in here. Notice this one's kind of interesting. So any of you done SharePoint upgrades? You've done upgrades from 2010 to 2013. You've had customers or users creating evaluation sites. Well, those evaluation sites will actually get indexed. So you might end up with duplicate copies of content in the search index because of that evaluation process. So what we do on all our platforms, sorry, it's a bit difficult to read. Basically a crawl rule that just says exclude everything with minus hyphen eval. So it's a useful tip if you're running evaluation sites. Otherwise people get confused. They find things in the wrong site when they're searching for stuff, and they go and make a change in the eval site, for example, that then gets deleted. Name mappings are the same. There's nothing in here. This is all no difference. File types, big white screen. So it all looks the same as it did before. There's very little in terms of changes in here. Obviously, behind the scenes, file types is different. The engine's different. We use format handlers now to process as many of these documents as we can. If we can't process with a format handler, we'll fall back to a generic ifilter. If we can't format with an ifilter, then we can't index the content. Index reset, I obviously don't want to press. Although it is nice now, it will give you 2 warnings before it blows away your entire search index instead of the 1 previously. Pause resume is useful, that's new. So it's simple in that it just says, do you really want to pause the index? It doesn't say much more than that. And I can't show it yet, whatever it's gone. Anyway. If you're running continual crawl, there is no way to go into that content source and say pause the crawl. So one thing we do quite frequently is we'll pause a crawl for patching purposes, for example. It's a useful thing to do. You're going to patch your web front end. You don't want your index server to generate a load of errors. So you pause a crawl. You can't pause a continual crawl. The only thing you can, not on a single content source, you have to pause the entire thing. Because it's that single cycle that's constantly running, you have to go in here and pause it, then you can make your changes somewhere else to prevent errors from registering. There's no way to do it on a content source by content source basis. If you want to stop a continual crawl, there's 2 ways to do it. Well, there's one way to do it is you have to evict that content source from the continual crawl cycle. So you go in and edit the content source, you say, this is no longer a continual crawl content source, it's incremental and full, then you can stop it. Otherwise, you can't stop it crawling. It's just going to keep going forever. Crawler impact rules remain the same. I haven't got a rule to add, but basically it's the same thing. What I want to do in terms of frequencies and crawl types, so I would say, okay, I want to do star.microsoft.com, which I can't spell. And I want to modify my changes. So this is important. This number hasn't changed in 2007, in 2010. In fast content SSA, it was the same. It was 8, which basically saying, make me 8 simultaneous requests every time I go back to my content source and look for data. In 2007, the recommendation was you never really change this value. In 2010, that value was, there wasn't really a hard recommendation that said you should change it, but I've run, if I reset a search index, for example, or ran into some level of index corruption, we needed to fix something, and I needed to get our index up to speed very quickly. Leaving it at 8 doesn't do that. It takes time. I've run this thing up to like 116, which really pumps the threads up, puts a lot of pressure on your web front ends. So if you're going to do this, think about having a dedicated crawl target. So the way you would modify this value, you could just go in here and say, okay, we're going to make it 256 or something. So we want to take the whole system down. Just be wary. Anyone here work for, no, I won't say the company name. Has anyone had a PFE engagement with me previously? Okay, I can talk about it then. So I managed to work, I was working with a customer who asked me to modify this value because they wanted to see what the impact was. And they wanted me to crawl their company-wide intranet. This was a very large company with about 65,000 employees. And their company intranet, I didn't know, was running on a 4-proc Pentium 200, single machine. All right, and I hit it. In fact, I hit it with about 164 threads. And what happened? Help desk lit up. Internet's down. It wasn't down, it's just that this thing was crushing it. You want to do a denial of service attack? This is how you do it. So just be wary of that one. Things will go wrong. You will break things. Go back. Other things like authoritative pages remain the same. So we still have that ability to add what we call authoritative pages. By default, come on, the first authoritative page in your site will always be the first URL you create, apart from central admin. So be careful, because in SharePoint, in 365 Dedicated, what's the first web application we create? It's the DR web application that we use for doing things like content DB attach and simple backups and restores. So in a lot of our farms, we didn't realize something was going wrong with search. It was because the DR web application was classed as the most authoritative web application. So where all the real content was being deprecated in the search results because it wasn't classed as authoritative. So just be wary. It will go by default. The first web app you create will end up in here. And basically it says that the closer your search result is to that website, the higher in the search index it will appear from a result perspective. These are where things change. So result sources, query rules, and client types is very different. Result sources, yeah, we've got a few minutes. So I don't think I need to go to my backup slides, so we can probably go through this pretty quickly. So result sources, the concept of where is my result going to come from. So those of you who be familiar with Search Federation and connecting to federated sources, this is replace federation. So what we're saying is now we create a result source that points to another location. But you build it exactly the same way. So exactly like building a connection to a remote location. We have some out of the box down here, and we have some defined for this search service application. You can define your own at the site collection level. So you can have your own site. If you've got your own search service, search center and your own site collection, you can create your own result source just for your site collection that's pointing out to somewhere else. Be careful with the federated side of things, though. If you want to do something like, for example, point this at Office 365 to your tenant, you're going to run into issues. There's authentication and identity issues you need to get over as well. If you want to talk about that, we can do later. Query rules are effectively replaced the old best bets and keywords. So now we're using query rules. So let me just load a query. So if I want to search my local search index, I can build a query rule. So this is just a simple one, but Agnes is going to do a bit on this, I think. But the query rule you could build would be, say, something like, well, whenever someone searches for Bob, do a parallel search or add the word William to the search. That's a bad Bill and William. Whenever someone searches for ADFS, also search for Federation. Those kind of things you would add keywords and synonyms in that respect. If you want to create visual best bets or best bets, you would do it in here. So do this, load this, and you basically say, when I do a search for this, I also do a search for that, or remove these terms, or query for this and add the other, and then propagate that as a result block inside my content sources, inside my actual data blocks. And again, the other sessions will show you how all this works. Query client types is the concept of throttling, and I'm going to ask Wayne, are you going to cover, you're doing throttling, right? You're not going to cover this. So the search engine this time also has throttling rules. So within the search service, we can decide which sources we're going to treat as being more of a higher priority than others. So for example, if you're using the e-discovery mechanism with Exchange and the e-discovery engine inside SharePoint, or search engine, using e-discovery type content sources, it's always considered a high priority. So it's the very last thing that will ever get throttled by the search service. Whereas a regular user on a search center might get throttled very easily. If you are writing a custom search engine or custom search interface to talk to SharePoint, there is a new item, new parameter to add to your query, which is client type. And you add that query, you add that to your query, and it recognizes one of these in here. And if we look at one, for example, let's go to content search high. We can see here that this is throttling top, high priority. Okay, so if you identify yourself as that, and it's a simple string in the query, you will fall into that bucket, so you're less likely to be throttled by anything else. If you don't identify yourself, or if you don't identify yourself as something in the list, if you identify yourself as something that's not in the list, you're immediately shoved into the tier 3 level. So just beware if people are writing custom search applications, they want high performance or not. Search schema is the same as before, manage metadata, not manage metadata, sorry, manage properties and crawl properties. There's a few simple differences in here. in that you can now modify properties to say which index within the index you want them to appear in. That's getting really deep and complex, but it's from a regular out-of-the-box search, you don't really need to be concerned with that. And then the final thing really to look at that I want to show you is the concept of the crawl log. So some things have changed in here. The key one for me that's changed more than, come on, any other I particularly like is the database view, which I've only got one database. So if I had more than one database, which I'm sorry I don't, unfortunately, what we would see in here, sorry for the resolution again, we'd see a count. So we'd see all of our content, all of our crawl DBs, and how many items were in each crawl DB. The system would also show a little yellow banner that would say, one of these databases has got too many things in. One's got 10 million items in, one's got 2 million items in. Would you like me to auto-balance it for you? And it'll go away and do it. So it's kind of a nice feature. Or you could do it yourself. When I say do it yourself, I mean click the button. You can't actually move the items yourself. And then finally, from an administrator, oh, go away. The other things I want to show you are really about the health rules. And the reason I needed this VM, not an empty VM, was because without a decent VM to show you, I have no real history of information. So this is a VM, this is a crawl rule showing, this is a graph showing like crawl rate per type. Some of the more interesting ones, crawl freshness. So if you were a search administrator and your users are complaining about problems and they're saying, well, my items aren't appearing in the index, you can go and look at this graph now and say, well, okay, well, your items in a my site, my aggregate freshness on a my site is less than a day. So if you're now telling me that your items, you added it 2 days ago and it's not appearing in search, there's a good chance something's wrong. Either we're not indexing that item for some reason, it's a file type we don't support, we can't access it, the search engine can't reach it, something like that. And then you can see a kind of a spread of the distribution. So in this, on the my site's perspective, 56% of all the items are less than 12 hours from being indexed. So it kind of gets you a feel for how fresh the index is. So if you're looking for a particular target, less than 15 minutes, for example, this is where you can come in and measure it and see how it's doing. I don't have continuous crawl running on this one, but the continuous crawl process would show us information, not in this one, but it would show us information about the individual content sources within the continual crawl cycle and where they are and where they're up to and how many items have been processed. And then probably one of the single most important reports would be your query latency. So the classic thing that I always get from my 365 dedicated customers is search is too slow. We're not getting results quickly enough. So I go to this graph and I have a look in here and I can see that, well, actually, you know, at this point in time, I was hitting pretty poor in terms of query latency. So 150 milliseconds, actually that's not bad. 150 milliseconds, but if you look at the percentile, which you can't see, sorry for this. There's a legend which shows the percentile. Oh, there it is, down the bottom. So I can see that at this point in time here, at say, can you see? Oh, that's easier. It's only pointing. At 8 p.m. on the 14th of April, I had about the 95th percentile of all my search results were being returned in less than 150 milliseconds. That's pretty fast from any search engine. If people were complaining, then I might start to see some peaks up here. If I saw the 95th percentile being kind of up in the 10,000 milliseconds level, I'd be seriously concerned that I had a problem with the search engine. So you can kind of use this data to go and build a story, find out what's wrong with the system. So I recognize that I'm just supposed to run out of time now. We are on a lunchtime session, so if anyone wants to hang around, you can do. These things like query suggestions, search dictionaries and things will all be covered, I think, by Agnes anyway. One other graph I want to show you in here, if I switch back to the slides, which I'm pretty much done with anyway, is main flow. So in this one, you get to see information about the rate of queries and the speed that the system's actually handling them. So it's a bit difficult to see if you can see it in the bottom. We're seeing the queries per minute, we're seeing the query latency, and we're actually seeing them by individual sections as well. So I'm knowing here, for example, that my layout selection, so which display template am I going to use to service those search results, could be taking way longer than everything else. So perhaps there's something wrong with it. The JavaScript inside that layout is not good. So the actual, the actual building of the search results to send back to the end user is not performing very well. So there's all kinds of things like that you can look at to interrogate the system. There's way too many of these things to go through right now, but that's kind of where this demo was done. I think I'm struggling with the screen resolution, I'm afraid. So all these are the bits down here. The rest of these slides were there in case we failed. So to finish off, I'm going to give you a clue because you've just seen the answer.